Hi everyone, this is Dr. Aeronautics. Welcome to exactly back where we left off. We are sitting on the ground here of Enceladus, which is orbiting low over Saturn. The good news is, I think in the last episode I figured out how to get rid of the annoying white flashes. Now I will still see them, but hopefully you won't see them. So the first thing we're going to do is just plan a trip to Titan and see exactly when we should leave Enceladus. So we're going to use Transx, and we're going to plan in the same way that we would plan Earth to Saturn. But instead of going from planet to planet, we're going from moon to moon. So it's, like I said, a solar system in miniature. So we're going to escape Enceladus, and then we're going to select planets or moons, and this one should be very easy. It's just 2 clicks because Titan is the largest moon of Saturn, and it looks like we're at a very bad orientation right now, which means we're going to be waiting some time before we take off here. Okay, so the first step is to add some prograde velocity. Won't take much because even though I said we're low, we're still relatively high. Much higher than where we were before. So as you can see, we come nowhere near an approach. That's not going to work. So what we're going to have to do is change the time that we leave. Now, I think I want to start this adjusting on fine because Enceladus goes around like once every 2 days. So the stay is not going to be long. Yeah, there we go. That's what I thought. Not much. And that's pretty close to what we're looking for. That's even better. So I'm going to refine this now. Go down to fine. And we're basically going to trim all of this up. And once I get a collision course, which for now is what I want, we'll go ahead and plan using that. That's good enough. So, and the inclination is actually pretty good where it is right there. So I'm actually going to leave that because there's a pretty good chance that as the orbit decays, it's going to decay in one direction or another direction over time. So if I translate in space, it'll be easy to fix that inclination. Remember, we're targeting Sionisque Lacus, which is at 47 degrees south, so I need something higher than like a 48 degree inclination to be able to get there at some point. So the next thing I'm going to do is take a look at the ejection date here, and we're going to work backwards from where we went before. So I'm going to come over here into the calculation workbook here, the mission information table, go down to the scratch zone and start entering some information. So from here we have the ejection date super 61144.6886, and that's going to be known as the Enceladus ejection date. Okay, and now the next thing that I want to know is exactly where I am on the surface of Enceladus. So, and that's relative to the velocity vector. Okay, so we're actually at about 180 degrees from the ejection location that we want to be, which is on the night side of Enceladus. So I'm going to put here the ejection orbit traveled, and we're going to say 0.5 for half the orbit. Now the next thing that I need is the time that it takes us to go around Enceladus.
That's not the number that I need. So, square root of the semi-major axis cubed, which is going to be 269,000 meters, and that's cubed, divided by g, which is big G, 6.67 times 10 to the minus 11, times the mass of Enceladus, which I always forget, but I think it's something like 2 times 10 to the 20th kilograms. And if this comes anywhere near a couple hours, we'll know that this is right. Okay, yeah, that looks like a good equation. I just want to confirm the mass of Enceladus real quick. 1.079 times 10 to the 20. Okay, so that is time to travel to ejection point. And then if I divide, we can get a modified Julian subtraction. Divide by, let's see, that's in seconds. So I need to divide by 86,400 to get modified Julian date. And let's see, yes, Enceladus ejection date, subtract the modified Julian date subtraction. That's our takeoff time, 61144.62. And it's 61143.62. So we're going to spend exactly 24 hours on the surface of Enceladus. And in real life, we'd be able to EVA, but due to some gravitational glitches, we won't be able to do that. Don't worry, we're not going to have this on Titan. Remember what I said, it's the gravity there is 10,000 times stronger than the relationship with Saturn. So we should not have these issues at all.
That's pretty cool. We're getting a close pass with Nemus right now. And it looks like currently I am unable to see any planets in the inner solar system. None whatsoever. That's how you know we're really far out. Okay, it's well daytime on Enceladus now, so you can actually see the detail in quite a bit more fashion than we would before. You can kind of see we're landed on a snowbank here, and there's some cracks, longitudinal cracks to either side. We would be sampling those in real life using EVAs and seeing what all is there. But you can see now on the MFD in the lower left-hand screen that we are currently in a much better position to fly to Titan. And if we take a look at the solution actually looks better now than it did before. So just to confirm, we have a prograde velocity, no outward, and no plane change. So that actually works out pretty well. So it is 0.601. So at this point, what we're going to do is do our ground cockpit startup, at least a portion of that. So we're going to check the damaged systems first. Okay, test the warning lights. Okay, MFD power is on, although I usually like to put TransX on this monitor. Good. We're going to take off at about heading 39 degrees. Trip has been planned, launch time has been determined, time has been skipped. We're going to turn the HUD on surface. HUD color. We're in the Saturn system, so we want blue. Secondary HUD, free. And we're going to go ahead and record some masses right now, because we will be taking off shortly. Okay, so in our table here, we're going to do an Enceladus ascent, but before then we need to actually copy things in here, right? So what I need is my current mass, which is going to be 31534.686. Should be a little bit lighter than right here. Looks like a kilogram lighter because of the oxygen usage. V1 we know is going to be 0, V2 is going to be 0 because we didn't go anywhere, and the mass final is the current mass, 31534.686. Okay, so now that says we used 0 on the surface, and we have used 0 on the surface. So now what we need to do is take a look at our current fuel level, which is 2574.4, and we're expecting it to be the same as what was after landing, because again, no fuel used, and the mass before this burn, which is 31534.685 kilograms. V1 is 0, but that's all we know, because there's going to be V2 and mass final. So this next maneuver we're going to do is an ascent. So we're going to do it in 2 parts, because Enceladus has such low gravity. What we're going to do is we're going to run the hover engines in a straight vertical line until we reach an apogee of an apogee radius of 269 kilometers. We're going to cut the engines off and coast up to that position. Once we get there, then we're going to turn to 55 degrees heading, and then fire the engines to get into orbit, and that will be this maneuver. Okay, back to the spacecraft. We recorded the shift masses. We're going to configure the multifunctional displays. So I actually want orbit done, and I want frame of the equator, projection ship, distance and radius, because that's what I'm going to use. We're going to get into a 20-kilometer rise, and for the time being I'm going to go over to surface. We're going to turn the tertiary HUD on here. Temperature display, just degrees, well, I had degrees centigrade. I'm okay with degrees Kelvin, because there's no atmosphere again. Okay, the next step has the APU going on and closing a number of doors. We have a note to grapple cargo if needed. Let's just check and make sure that everything is still aboard. Okay, we have the UTCO payload adapter, and its current mass is 7,395 kilograms. So let me add up everything except the probe, which is now disintegrated in Titan, or not Titan, Saturn. And I'm getting 7,398 kilograms. That's close enough. Plus or minus 3 kilograms is probably going to happen due to the way that this is done. So we'll return to the upper panel just to confirm. And just make sure that we don't have anything sitting around or under the ship. No, we do not. Okay. Alright, make sure that the cargo bay doors are closed. They are closed. The inner and outer airlock doors are closed. The nose cone is closed. The cabin hatch is closed. We have checked the fuel. So we'll put nav, beacon, and strobe on. Actually, no, we won't. There's no need, there's no reason to out here. Alright, the next thing we're going to do is activate RCS mode. I'm not touching anything in the cockpit right now.
Rotation.
Okay. External cooling is not a factor because we're not on, we don't have access to an EPU. Now currently ready for taxi. So now I'm going to go to my VTO checklist here. Radiator is desired. It is open. That's okay. On Titan, we will close it. Hover doors open. Retro doors open. Autopilot as desired. That is the last thing that we're going to do. So we're going to go to 0, actually it's 1, 2. Yeah, I think we want the attitude hold autopilot. I'll take care of the engine myself. So that's it. We're now waiting for our ultimate departure time of 61142.62. And that's modified Julian date up in the upper right here. So we have 0.014 days to go, which is probably somewhere in the vicinity of half an hour. So we're going to go ahead and time skip one more time to that point in time. Okay, 0.6198. That's close enough for takeoff. Now, one thing I wanted to mention with the secondary HUD here is that if you look at PEA and APA, those are set to megameters. So it's referencing the gravitationally dominant body of Saturn, and even with changing the reference in orbit MFD, it doesn't look like there's any way to force it to Enceladus. So that's just important to know. Okay, it's time to go. We're going to go ahead and activate its attitude hold autopilot now. And here we go. Adding hover thrust to take off.
Lift off.
Okay, we're off the ground. Very quickly, I'm going to switch over to orbit because this isn't going to take long at all. We want to cut the engines once we see 269 on there. .268, and that's it. So we're going to coast now up to our altitude. It looks like it's going to take about 10 to 11 minutes to get there. So at this point, I'm pretty satisfied that we're not going to crash into the ground. So we're going to, at this point, disengage the attitude hold autopilot. And we're going to slew over to our target heading, which was, I think it was like 38 degrees. I should have noted that before I took off, but anyhow. And I'm going to leave the gear out for the time being. There's no air that we're encountering, so there's no real need to stow that right now. What I'm going to do is I'm going to wait until we're in a stable orbit, and I'm going to do all three at the same time. I'm going to do hover, retro, and gear all at the same time, and that's to conserve APU fuel, which is probably going to be consumed like heck in a couple minutes, hours sim time, where we're going to enter Titan's atmosphere. Alright, so we've got 10 minutes to apogee, so we'll go ahead and come back when we reach that. Okay, so we're now about 30 seconds from apogee. So all we're going to do is run the engines for about 6 seconds to get into a circular orbit around Enceladus. So I'm facing in the approximate direction, which was 38 degrees. That's going to change a little bit after takeoff. And you should see relative inclination in the lower right change quite a bit. So we're going to burn on 3. 5, 4, 3. And I actually overburned there. So we have a V2 of 132 and a final ship mass of 31518.496. So that managed to use only 188 meters per second. We actually ended up saving there. Fuel before the next burn, we can put that down now. That's 2558.3. Looks good. A very great flat line. So we gained back some there, but now I have to address something else, and that would be related to my relative inclination. So it told me to take off heading 38 degrees, which I did. I mean, it did a couple minutes ago. Maybe I didn't look at it again. Unfortunately, that has put us into a 85-degree relative inclination orbit, which is the exact wrong orbit to be in. So I'm going to see if I can try to replan that. So what I can do is I can adjust this ejection orientation course, which I said was absolute magic. And what I can try to do here, that goes down to 55 degrees. So let's take a look here. We want Enceladus, and we want to target ELS. And I want inclination and land. So I want 85.16 and a land of 159.5. So that's saying we're in a 55-degree orbit. It's going to take about 6.5 seconds of thrust. Let me go back to my calculator here and just get a quick estimate for timing here. Required delta V of 152 meters per second, and I was factoring in 9. So if I add the two, we're planning 245. If I add 188 plus, I think I said 152, that gives us 340. So in these, is planning 197, not 197, 245 and 340. That's a 95 meter per second overburn. That's unfortunate, but it's tolerable. I'm going to put down here in the action items to say what happened on the Enceladus ascent to cause an 87-degree inclination after following 38 degrees takeoff heading. Most likely what it was is I looked at 38 degrees before the time skip, and the time skip moved it by 90 degrees. That's my hope. Because if I followed what Transx said and I got here, then it is broken as it could possibly be. Okay, well, we're going to have to do a long plane change now, so we're going to skip forward in time to when it's time to do that. Okay, so we're about a minute before the burn, and even though it says that we should be burning for 6 seconds, I want to burn for 30, because remember, the orbit will precess around, and we have to stay with that precession. So let's real quick get our numbers. 255.8 or 2558.3 in the tank, yes. Mass of the ship before the burn, 31518.496. 0.449. V1, 120.6. Alright, we'll switch over to the orbit view now, and let's see, we're burning on an ascending node, trying to lower the inclination, which means we need to burn descending. So I'm going to burn at approximately 1/10 the normal thrust that we would use. We'll ignite our engines 30 seconds out from the node. We get in line with our velocity vector here to make maneuvering to stay with that cross easier. Okay, here it comes. 33, 32, 31. All right, looking for 10% thrust. All right, now I got a slew to stay with this thing. And view that my relative inclination is coming down. Down to 27 degrees now. 24, 23, 20 degrees. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and cut off. Perfect. 0.1 degrees. Not bad. Okay. Go ahead and kill rotation here. Come back to our spreadsheet. V2 is 125.2. Alright, so we've precessed the orbit quite a, or I shouldn't say precessed, we've added velocity to the orbit quite a bit here. So now we're in a somewhat oval-shaped orbit. That should be okay. And then our final mass of the ship after burnout is 31508.073, and that used 120 meters per second as expected. And current situation in the fuel 2548.0. So we're currently in need of 2196, and we have 2548. So that's a difference of looks like 340 kilograms margin. Taking a look here, you can see we fell back a little bit, but we've still got a healthy margin. So we're going to start operations to get to Titan now. So at this point, I'm going to stow everything. We'll turn the APU on. And we're going to bring the gear up.
Gear up. Gear up and locked.
Close the retro and hover doors. Okay, that's it. APU off. I'm surprised this isn't telling me when to begin the burn. Normally it'll count down. I'm going to have to do the work on my own, if that's the case. Okay, so we're going to be just a little bit late on the burn here. We're going to be at 718, it looks like. Which means we need some outward in there to counteract that.
Since TransX won't seem to give me the numbers that I need, I'm going to have to do it myself. So the first thing that we're going to have to do is come down here to Patch Conic. And we're going to put in the mass of Saturn. So I think that's like 5 point... I better get exact number. 5.683 times 10 to the 26 kilograms. The departure semi-major axis of 269 kilometers. The mass of the departure body, that's going to be Enceladus, 1.08 times 10 to the 20th kilograms. Wait a minute. Departure. No, that's the semi-major axis of Enceladus. That's 238 times 10 to the 6. Radius of the departure, parking orbit, that's 269 kilometers. Arrival semi-major axis, that's going to be the semi-major axis of Titan. That's 1.222 times 10 to the 9th meters. The mass of Titan, which is going to be something times 10 to the 23rd, 1.346 times 10 to the 23rd. So you can see how much larger Titan is. It's more than 1,000 times more massive than Enceladus. And the radius of the arrival orbit. Okay, so the first burn is 3,551 meters per second. But we need to do a burn vector here. So we'll round up to 3,552. So for X, we're going to say 3,552. There's no, there's no relative inclination. So we'll go ahead and do the outward, which is 556. And that's 3,595. Now we need maneuver timing. So we're going to burn and a yaw of 9 degrees. 3,595. Ship initial mass should be close to what we have now, 31,507.56. Tank capacity. Let's see, the ISP of the engine, that doesn't change. Engine force doesn't change. So we're going to do a 180-second burn, and it's going to be 94 seconds. Alright, so the last thing that I wanted to do was check and see how that compares with what I was planning. So I'm showing a 3595 meter per second delta V, and I was planning 3551. That's acceptable. That's only 45 meters per second off. All right, so the last thing to do is just simply fast forward in time until we reach that point where we prepare to burn.
Okay, TransX is being really difficult today. We're going to begin the burn without a countdown. We're basically at the periapsis now, and it's not going to matter in hindsight because Enceladus is so weak gravitationally that any yawing that we're going to do is going to induce more error. So normally I would not allow this to happen. I would solve the issue with TransX, but we should not have an issue at this point because, like I said, Enceladus is not contributing much to the force. So in any case, here we go. Actually, wait, first the numbers real quick. Let's see. 2548, ship mass 31,507.012. I did a little bit of adjustments to the inclination with the RCS system. Let's see, V1 143.6, so that's why the mass is a little bit off. All right, then we do V2 mass final. Here we go. the heck is Enceladus hiding at? Oh, there it is. It's incredible how quick you move relative to these small moons. You never see speeds like this when you're talking a body the size of the Earth. Alright, looks like we need a little bit more outward at this point. So I'm going to yaw to 10 degrees now. Okay, the outward situation's looking better. I'm gonna yaw to 5 degrees now. And go back to 10. Alright, we're getting really close here. Alright, pulling the power back. Okay, main engine cutoff. I think that was pretty good. We're going to have to get out away from Enceladus before we'll be able to know for sure. Now, isn't that just awesome? Departing the snow moon Enceladus. Taking awesome pictures is absolutely mandatory. Alright, let's get the numbers entered into the spreadsheet here. It looks good enough to be able to... Oh, wow, that was that was quick. Okay, yeah, it's good. It is good. We're actually still on a... you can orbit Titan 20 megameters out. So, at this point, it's insane, right? We just left, like, not even 4 minutes ago, and we're already out of the gravitational influence of Enceladus, even when it comes to transects. Like, it's totally insignificant at this point, 1%. So we're going to switch over to Saturn at this point, go to the HUD, and look at how far out we're going to go. Anyway, numbers. V2. Oh, I shouldn't have done that. Because now I missed V2. I should have done that after I got the velocity. And it's not going to slow down much because, like, Enceladus is gravitationally insignificant. 4117. And let's see, final mass. 2203.9. So we're hoping for 3395, I think. Whoa, no. That's no. What? Oh, mass final. scared me. I was like, what? 31162.801. Yeah, not the current mass of the tank. Alright, so it was 30 meters per second more at 4,023. Current tank level 2203.9, and we need 1913. So we currently sit about 290 meters per second above the abort mass. So we're continuing on to Titan, and you can see our big drop here. Nothing to be alarmed at, but that margin's getting smaller. Just FYI. Okay, our current distance from Enceladus has increased, and it is now time. This is stabilized out. It's time to plan mid-course correction 1. I'm good with that, given that things seem stable right now. So let's see. We've got... there we go. Go back here to get to my window. Okay, not bad. 63, and I think I planned 355, right? Because we used the 10% rule. So that was actually a good initial burn, really. We're going to be... looks like pretty close to the pole, so... we'll go ahead and slew up this way. I think that's the first time I've ever gotten the X right on the spot. Okay, let's get our numbers. Fuel before, 2203.9, yes. And then mass of the ship, 31162.642. And then V1, currently 15,840. We've got 63 meters per second. Burning in 3, 2, 1, now. Okay, that's it. Let's see how we did. Maneuver mode off. And current orbit has 180 kilometers and an inclination of 48.65 degrees. And that's a good burn. So we'll call that complete at this point. Let's get the numbers here. V2, 15,850. So we accelerated by 10 meters per second, and the rest of the 50 meters per second went into the plane change, and we're expecting a burn of, I think, 63 meters per second to show up in the window here. And the mass of the ship at burnout, 31157.29 or 1. Yep, 62.9, good. And the current mass of the ship for the next maneuver, 2198.6. Okay, so that should have saved us a significant amount of margin, almost 300 meters per second. So we're not going down quite as quickly anymore. Looking good, continuing on to Titan. got a close pass with Tethys right now. Okay, we're pretty far out now, and it's time to plan mid-course correction maneuver 2. By the way, Enceladus is that white dot right there transiting Saturn. So, let's see, we've decayed a little bit to 5,000 meters, which is high. That's higher than I want. And you can kind of see how much the orbit gets bent by Titan. Titan is a titan among moons. So even though we're going to be going past it at like half the orbital velocity, Titan still has enough gravitational authority to swing our orbit. So that's a sign that it's a very, very big body. So we went through 30, that's 750. I might have waited a little bit too long on mid-course correction maneuver 2. Nope, actually, let's go back to 25. Okay, I'm going to call this good. I should be able to fix this with translational thrusters, but 645 and 52 degrees is okay for me. So we have 23.5. Good. It is actually less than I planned, or budgeted for, rather. I think this one's mostly pro-grade. Okay, getting the numbers, 2198.6, that's still correct, and the ship mass is currently 31155.428. What is this? V1 is 4679. So you see how much our Saturnian orbital velocity was 15.8 kilometers per second, and now it's 4.7. That's how far out we are. So Saturn now is even very forgiving on the when I get something wrong. Well, we're only at half the Earth's orbital velocity. Then we got D2 and mass 5. Okay, going back to the ship here. It is no plane change, just a little bit of outward here. And we're expecting 23.5 seconds, or not seconds, meters per second. And I budgeted 36. So here we go. Here's a quick mid-course correction, maneuver 2. That's it. Let's come out of maneuver mode. And we're showing 635 kilometers, inclination 52 degrees. So that's successful mid-course correction maneuver, V2 4699. And mass of the ship at burnout, 31153.377. Yep, 24 meters per second. That's looking good. And then Titan orbit insertion mass will start at 2196.6. Okay, we are growing a healthy margin. So we are go to enter Titan orbit. At this point, we're just going to fast forward until we're on Titan approach, and we'll start adjusting the orbit to exactly where we want it using RCS translational thrusters. Okay, so it's kind of really hard to see, but Titan is just to the left of the prograde velocity vector there. We're approaching on the night side. And what I want to do at this point is fix my orbit so that it's where it should be. So I've translated around to the prograde velocity vector of Titan loaded in the orbit MFD. So now
Translation.
we're going to introduce a little bit of translation to the left. That should lower our orbit here down to where we want it to be, which is 2905, 330 kilometers, I believe. 2905 minus major radius 2575 equals 330.
Rotation.
Okay, that's it. So we're 330 kilometers and 53.57 degrees. This is an acceptable orbit. All we got to do now is just keep an eye on it as we approach. So for the time being, we'll go forward again until we get closer, and then we'll do the arrival burn. Okay, it's come time to adjust our orbit once more.
Translation.
So we're 6 kilometers off now. So I'm going to perform the exact same translation burn, and that's it. Now I over maneuver just a little bit, but we're trending in a rising direction, so the minimum altitude might end up being 330 anyway.
Rotation.
So I'm just going to leave it as. Now, if I go outside, I'm going to point the nose of the ship towards Titan. If you look very closely, you can see a blue hydrocarbon haze above the orange smog clouds. It's quite a sky from the surface of Titan, let me tell you. And mind you, there's an atmosphere and a half of air there compared with the Earth. So there is more air there than on planet Earth. Okay, well, this is a pleasant, well, it shouldn't be a surprise. It's a change. Check this out. Auto-reference. That's strange. Why did it choose Saturn? If you'll notice that Saturn is actually not the gravitationally most dominant body anymore. It's Titan. So I'm not sure why auto-reference did that. You see, Titan is now green. So it is actually in control now. And we're getting really close. The altitude's been fluctuating up and down like a sine wave. We don't have to get it exact. The next thing that I need to do, let's see if we can change the view to be focus. The next thing we want to do is verify our burn duration. So we want this circular delta is the velocity that we want. So we can skip the first part of what I'm doing and skip to the maneuver timing. So down here, it's 1820. So thankfully a smaller end burn. Ship initial mass is going to be 31,150.2. And nothing else changes. So I'm showing a 93-second burn, and we're going to start the burn 47 seconds before periapsis. All right, we're just going to keep marching forward here until our until it's time for the burn, or we need to adjust the orbit one more time, whichever occurs first. Now, we could aero capture if we wanted to, but I do not want to because I am targeting Sinus Cape Lacus, and I need to figure out where that is to be able to determine how long I'm going to remain in orbit. So, kind of hard to see, but Titan's getting really big out the window. That haze is really showing up now. Okay, something relatively unexpected has happened. We're just 5 kilometers under the targeted orbit, and I had some calculations that I worked out that should work. However, I've noticed that we have the air flight control surfaces are responding, and that's highly disturbing. So at this point, I'm going to turn to an aero capture trajectory, and I'm a little bit concerned about our mounting dynamic pressure here. We're not expecting this. Okay, we're going to have an early re-entry. So I'm going to set attitude, hold, angle of attack, set 45 degrees.
APU auto start.
Engage.
Center of
APU's
gravity
auto-started.
shift online.
Actually, we're going above the orbital speed. Let's use 55 degrees. Looks like we're accelerating at about 1 meter per second squared. So that
Mach
shouldn't
13.
cause a critical wing loading. Well, the good news is this is actually going to save some fuel. I know it's kind of weird, but it despite the fact that this is an unintentional mistake, and let's take that down. I'm going to write that down into the actionable items in the flight. At 600 kilometers, Titan's atmosphere was significant. Why did you not realize this would happen? Now, what it might be is at Titan orbital velocity, which is twice as low, it's going to be 4 times less energetic. So it might have had something to do with that. Let's see, we're at 3.4 kilopascal. I think, let's take a look at our temperatures. We're at, all right, let's do a re-entry check.
Re-entry check. All systems green.
Okay, I think we still have the ability to swing around if we need to, but we might not need to. We're actually decelerating at half a G right now, which is by far the most amount of stuff we've
Mach
ever done.
12.
So let's prepare for atmospheric entry, shall we? Perform the plane change burn, not applicable. Orbit, we're not solving re-entry at this point. Add ranges to determine distance for burn. Now, we're skipping all that. A few minutes before the burn time, so skip all the solver stuff. Check everything is closed. Turn the AF control surfaces to pitch. Left MFD to orbit. Right MFD to aerobrake. We're actually not doing that right now. Slew to the burn, or the re-entry attitude in this case. Aerobrake MFD checked against limits.
Mach 11.
Too late for that. Set radios for landing. We're not landing right now. There's no radios to use. APU on. Retro and hover doors closed. Radiator stowed. Perform the re-entry check. That's done. Temperature display degrees centigrade. Engage autopilot. Done. Display 3 for temperatures. Control the autopilot setting. HUD re-entry. Secondary HUD surface.
Mach 10.
Other way around. HUD color as desired. We'll keep blue. Secondary HUD 1, I've done that. Left MFD surface, not quite yet. Alright, we're going deeper. We actually want to skip at this point, so... Alright, we made an aero capture. We may have just saved 2.1 kilometers per second here.
Mach 9.
So at this point, I'm really not concerned about bouncing out of the atmosphere because we're going to stay here. It's funny, unintentional aero capture here. Alright, so at this point I want to leave the atmosphere before it causes me to decelerate if possible. So what I'm doing now is I'm lowering the angle of attack down to our minimum of 30 degrees. This is going to cause us to skip off of the atmosphere. And once the skip maneuver has completed, what I'm going to do is turn into the oncoming airstream, if possible, and that's going to streamline us for minimum deceleration. Alright, so the skip maneuver has completed. I'm going to try, watching the wing load here, to point my nose into the wind now. But I must be very careful.
Mach 7.
Okay, we've completed it, so we're gonna, at this point, set the angle of attack to 0. And we're gonna try to ride out the atmosphere as best as we can. Let's see, am I able to disable attitude hold at this point? Possibly. Yes, because the air flight, because the air flight control surfaces are working. There's no center of gravity shift taking place. And we're coming out. Very nice. Okay, in that case, the autopilot is off. We'll switch back to temperatures. It's too much for the radiator.
APU offline.
Oh, I forgot to shut off the AF control surfaces. I don't have a checklist for what I just did. We did an aero capture, and we don't have an aero capture checklist. So, that's why I'm seeing red errors there. So when the dynamic pressure gets below 1 kilopascal, we'll open up the radiator again. And I believe I've still used no main engine to do this. 2196 points. Yeah, I've used absolutely no main engine to get into orbit around Titan. That worked pretty well. So maybe I will add this to the actionable items. Note that 330 kilometers is, however, a great altitude to perform aero capture without re-entry, or I should say atmospheric entry, occurring. So that wasn't as I planned, but it ended up being all right. And actually, it ended up saving fuel because we didn't have to do that. Now, we will have to do the maneuver coming up. So what we're going to do, the game plan, is to ride up to the top of the orbit here. Okay, dynamic pressure's down. Time to open up the radiator. And then once we get to the top here, I am going to, well, first what I'm going to do is take a look at the surface and look at my dynamic pressure in pascals. When that gets below 10 pascals, I'm going to note our altitude, okay? And then once I know what our altitude is, then I'm going to say, okay, at the apoapsis, I'm going to raise my periapsis out of the atmosphere because it's causing a re-entry right now. Come around, swing to the low end, and then lower this one to circularize. Or would it be more efficient to do a... We could do an abscid line rotation. We'll turn this off. So we got up to 40 degrees, and we're coming down. Good. Okay, so I did the math, and abscid line rotation would cost me about 440 meters per second delta V. Just burning at the apogee and perigee to circularize would cost me 200 and like 240. So we will proceed with the apogee and perigee burns as planned. So the only thing that I need now is the proper altitude to be at. So we want to be a little bit higher than our current altitude. We'll just use where this red and green lines intersect. I should have known that this red line is drawn here to show you where the atmosphere becomes significant. But for some reason I thought it was wrong. Maybe that was because I changed atmospheric modules. I don't know. Okay, so it sounds like there's no atmosphere at this point. So it looks like the proper altitude to target is 730 kilometers, or if we go to orbit here and look at our current radius, looks like 3,300 is the radius to target. So I'm going to solve some math now for our apogee burn.
Alright, so real quick, we're on the vis viva. We're going to use this to solve the equation. So we've got the mass of Titan in here. Our current semi-major axis is, it's not 3.994, it's 2.994. The altitude that we'll be doing the burn at is 3,893 kilometers. Thus, we have V1 of 1270 meters per second. And this is the first burn, mind you. Okay? So then we're going to adjust our semi-major axis, and it's going to be adjusted so that the one half of the focus is 3,893, our apogee, but then our perigee we want to be 3,300 kilometers. So if I do apogee plus perigee over 2, then I get 3,597. And now I have V2 is 1455. So now if I add, burn 1 is going to be 185 meters per second. Then for the second burn, our semi-major axis will be the same, obviously, because we haven't burned. But now our altitude will be down at 3,300, and we want to circularize. So velocity 1 at this location is going to be 1716 meters per second. And now when we circularize, we're going to make our semi-major axis equal to our radius. And we got 1649 for V2. Thus, if I subtract, I'm showing 67 meters per second. Yes, 67 meters per second. So come over to the maneuver timing table here. Burn 1, 185. Ship initial mass, 31137.8. And none of that changes. So start burn 1 5 seconds before apoapsis. And we're just going to wait until that time.
Okay, we're now about 3 minutes from the burn. We're going to turn prograde. And we're going to get our numbers. Okay, just checking, 2196.6. Yep, absolutely no thrust needed to get us into orbit around Titan, thanks to our unexpected aero capture. So I expect to see a massive amount of savings after that. So we're finally using orbital insertion thrust now. Let's see. Mass initial, 31137.722. And let's see, is it time to get a V1? Wait a little bit longer to get a V1. Okay, we're now 30 seconds out from start of burn, so we'll get V1 1272. And we're going to burn until we approximately get to 1355. All right, here we go. 10, 9, 8, 7, 6, 5. And we want to burn to the periapsis says 3300. Okay, that's it. V2 1457. Ah, 1455, not 1355. Okay, plug in the numbers in. 1457. Empty mass 31122.020. That used 185 meters per second. It was exactly as planned. Although, that was just the first orbit insertion. We're going to do another one. I can use this second line down here for the second one. 2180.9. And save. Okay, so not really much to do now except to just sit and wait for us to get down to periapsis. Although, I guess I should figure out exactly when the maneuver should begin. This one will be, looks like just 67 meters per second. And the ship initial mass will change to 31122.019 kilograms. So we're going to start burn 2 seconds before. Periapsis. And it's going to be a retrograde burn. Until then. Okay, we're about 165 seconds before the burn now, so we're going to turn retrograde. And that's handy. If you look at the TransX MFD in the lower right, it's going to give us a circular delta, and that's reading 67, and I was planning 67. So that's in agreement. Very nice to see that. At this point, we'll grab our numbers. So we have 2180.9 kilograms in the tank, and our initial mass of the ship, 31121.883. And then, let's see, V1, our velocity should be changing by quite a bit, so I'm not going to grab this until it's just before the burn. Okay, 30 seconds before the burn. Holding retrograde. V1, 1720 something, I'll say, until we get down to 10 seconds. Okay, 1720 it is. 4, 3, 2. A little bit of an overburn. I can correct that with translation.
Translation.
So V2 1646 probably means I burned 73 meters per second. Empty mass 3115.619. Yeah, 73.7 meters per second. That was unnecessary. But look at it this way. It took us 258 meters per second to do Titan orbit insertion. We were planning 1688. So that's like a savings of 85%. And I knew that this was possible, but I didn't want to plan it, mainly because it makes the mission complicated exactly how much you do end up using. Because aerodynamics are very, very complicated. That being said, NASA uses these. If you were going to go to Titan, you would use this. Cassini-Huygens used it. It just makes more sense. And I wouldn't have been afraid to use it if we reached the abort criteria and had to abort the mission, and then found that my calculations are correct, or we made a stupid mistake afterwards, and I mentioned that I had more cards up my sleeve. This is one card that I have, and I used it unintentionally. Okay, we're now in a circular orbit. We can target Sinus Caglacus. That's the end of TransX. So we'll now move this one over to map. And let's see where we are. So we're targeting 42.5 north. And 81.88 east. So let me see if I can tell how close our ground track comes to that. So I think each one of these grid squares is supposed to be 30 degrees apart. We're crossing the equator right now, and we're at 106 degrees west, which means this intersection here, where my pointer is, that's going to be the equator and 90 west, equator and 60 west, equator and 30 west, equator and 0. So then we've got equator and 30 degrees, equator and 60 degrees, equator and 80 degrees would be about where the map edge is, and we're targeting 42 north. Oh man, we can make that in this orbit, and it's going to be a daytime re-entry. Man, talk about scoring gold. Okay, I'm going to we need to get to the orbit or the re-entry calculator now.
Okay, combining it with Solver 2B, this is by far my most complicated calculator. So, our apogee is currently 3,300. What is that in kilometers, though? I think that's 725 kilometers. Moon radius. Right, so if I did this plus 330,000, 2905. Okay, yeah, so that's the right number to use. Interface altitude. Well, let's see. Where did I start getting concerned? I think it was around 450 kilometers. So maybe we'll use 450 as the interface altitude. Eccentricity of the orbit currently 0.006. Inclination 79.14. Argument of perigee 99.53. True anomaly 261.04. And rotation rate, the rotation rate of Titan. I don't think it has to be anywhere near exact. It's something like 16 days, I think, times 86,400. 1382400. It's going to mean next to nothing in the time that it takes us to re-enter. And the mass, 1.346 times 10 to the 23rd. All right, so this is currently showing that we're going to swing down to 690 kilometers. So now I need to figure out exactly where I want to do the burn. So if I did an eccentricity of 0.1 degrees, that's going to give us a flight path angle of 5 degrees, which is pretty steep, but for Titan, that's acceptable. So now what I'm going to do is I'm going to look at this ground range from the burn in kilometers and intersect that with 450 kilometers. Sometimes I can't believe I built this thing because I forget how it works half of the time. There we go. Okay, 450. So we're going to use an angle, re-entry angle of 5.7. Then we're going to have a ground range of 3450. So now we go to 2B, and this is where it gets really crazy. All right, we're going to target a ground range of 4,000 kilometers. The reentry isn't going to happen exactly the way I planned, which is where you fly a vertical speed profile and then you leave. It's going to be a sinking profile, so it's going to be from 450 kilometers. I think the sink rate is something like 20 degrees in Earth's atmosphere, which for Titan it should be a little bit less than that, probably more like 15 degrees. So if we have 450 kilometers, then if I do sine of radians of 15 degrees, that gives us 116 kilometers range. So I'm going to say 116 kilometers for phase 2. And then phase 1, we'll use down till we get to 450 kilometers. 3,465 kilometers. Which means the ultimate reentry burn should occur 3,465 plus 116. 3,581 kilometers from the base. Now I have to equate this into in a latitude and longitude target.
Okay, I'm using base sync right now, and it seems like I'm getting some latitude here. 42.5. Longitude, ooh, that did something. 81.88. And that's where we are. So it's showing us about a third of an orbit away. Now, if I go to the map, are we about a third of an orbit away? Right up here, right where the daytime terminator is. That's 1/3. So here would be 2. Yes, I think that's right. I think base sync is our saving grace here. That's why I enabled it. Not sure what this ED thing does. Okay, all right. We want direct. That gives us a relative inclination readout. Direct. And you know what? It's time. Let's see. We're at a descending node. Or no, we're at an ascending node. You know what? I have some extra fuel. Let's do it. We're going to turn prograde or orbit plus here, and we're going to intentionally increase our inclination so that we intercept the base. And what I'm going to do is I'm going to use different end values for what I have in the Titan orbit insertion.
Rotation.
That puts us just 14 kilometers away from a direct interception. Okay, so now I need different V2 values here. 1656, 3167.995. And fuel before the next burn, 2127.7. Okay, so now we've used 820 planned 1688. So now we're up to 50% savings. But I mean, hey, look at how small that dip is compared with that one. We're okay with that, and we're okay to proceed with Titan deorbit operations. So at this time, we have a distance readout. We're now 5,890 kilometers from the base. And you remember I said we performed the deorbit burn at 3,581 kilometers. So now, let's see. I think I want target periapsis. Actually, wait, no, I want closest passage. Definitely one orbit, reference planet, it's auto-referenced. Ah, here we go. Re-entry angle in degrees. That's handy. I haven't used this MFD much because it's been a long time. I used to use it back in 2011 and 2012 for my commutes between the various systems that I created, the star systems, the ones that that contain Planet Blue Ball. That didn't do anything. What if I just said 4? It doesn't do anything. Oh, here we go. Deorbit program. Okay. Like, what am I supposed to gain here? Ah, okay. It's in kilometers. I was entering meters. Okay, so we want 450. There we go. And showing 88 meters per second. This is a handy little tool. I wish it told us, it says true longitude 35.94, and we're at 354. Well, let's compare it with the distance. So if I close this, can I go back into it? Yes, I can. So I'm showing about 800 more kilometers, but in any case, nothing will happen until we get to either on D orbit when we get to this gray line, or when we're 3,581 kilometers, whichever occurs first. And I'm hoping they occur at the same time. So we'll go ahead and skip forward to that point. Okay, so we're pretty much to the first one now. I'm showing 3,700 distance, and we're basically at the deorbit point. So these numbers are actually agreeing pretty darn well, which I'm very happy about. So we'll go ahead and turn retrograde now, and we'll do our burn. We're expecting 86 meters per second, and this is nice enough to tell us how long the burn will occur, just 4.4 seconds. So let's get the numbers. Prior to re-entry, we have 2127.7, mass 31,067.825, and V1 1652. Let's see what our distance is now. 3637. Okay, it looks like we're beyond it. So I'll go ahead and run the engines now. So we're going to count down from 4. Quick save. Alright, here we go. 4, 3, 2, 1, and that's it. What is that? The ship must be on a circular orbit before the deorbit. Oh, that's fine. Yeah, that's... Actually, that's... Oh, that's lame. My calculator can handle non-circular orbits. Maybe that's why I stopped using base sync. Anyway, I'll turn the deorbit mode off now, so we're gonna look, and at some point before this location we're going to re-enter. Alright, let's consult our atmospheric entry checklist. We're going to perform the plane change, which we've done, solved the orbit, determined the distance from the burn, got our burn plan, configure MFD map. We can't do that, but we use the base sync. Check airlock door and nose cone are closed. They are. Do the deorbiting burn, slew to the re-entry altitude, and check aero brake against limits for go, no-go to continue entry. Okay. So we're going to turn this, and that was a retrograde burn, so we're going to go ahead and turn prograde. And yeah, so I'm going to get the numbers in just a minute, but what I want to do, actually, I do need V2, 1566. And I went, whoops, that's the wrong way. It's about 40 to 45 degrees, right about there. So now what we're going to do is check this with aero brake, which is there. Okay, that's giving us a landing site of 7 north, 74 east, which is unacceptable. This re-entry path as it stands is actually unacceptable. Alright, in this case we're going to open up the retro doors, and we're going to have to check this a little bit at a time. That blows. So both my calculations and the re-entry, or the base sinks, were off as well. So I'm going to burn retrograde here. So we're using 0.1. I'm going to use 0.12 to start. And then I'm going to pitch up. I hate this sort of guess and check, but on a planet the size of Titan, it's forgiving. Alright, now we're 74 east and 17 north. So that was a change of about 10 degrees. And we need to change about 30 degrees. So let's do eccentricity to 1.6. Or 0.16 rather. Close enough, we'll check that. And we're looking for a landing site of 42.5 north, 81.88 east. Close, but no cheese. Try it one more time. This time we'll go to 1 point... let's go to 0.18. Alright, that's giving us 80 east, 36 north. A little bit more. I want 42 north. Alright, not happening. We'll use an eccentricity of 0.2. I guess what it was is I used the wrong re-entry angle anticipation. That's probably what happened. Alright, 40 north, 4280. 0.3 Gs. We can deploy an aero brake if we need to. For heating... It's this one. Or no. It's PG. There we go. .3 Gs. I'm looking for hull heating here. Oh, that's handy. Have various holds possible. Okay, I'm satisfied that we're done now. So now we need V2, 1482, the mass of the ship now, which is 31,051.888. We used 188, planned 130. It's not too bad, but I do want to know. Well, I did make calculations on the fly, so maybe that's a training thing. 2112.8 is left in the tank. And we need 1734 to continue the mission. We're go to re-enter on Titan. Folks, we are going to, well, I did say we're 500 feet above, and I'm like, nope. But we're go to at least enter the atmosphere. Okay, dawn is breaking, and now you can start to see the two layers of Titan's atmosphere. So I'm going to use the ship as a pointer here, right? You have space. And I'm going to point the nose right at the edge. That blue stuff is a type of hydrocarbon haze. And then deeper in, there are the cloud layers. And those are the opaque methane clouds that you can't see through. And then deeper down, it's starting to appear where the nose is pointing. That's the actual surface. So it's going to kind of look like there's going to be two layers. And the thing that I love about Titan is the atmosphere will start to turn blue, and then suddenly it's going to turn orange. And that is really neat. That's why I was looking forward to it. That's why I wanted to do it during the day. All right, back to the checklist. We are go to continue the re-entry after initially being no-go, but in a safe way. Set radios for landing. There's nothing to set. And then we've got 5 minutes from the re-entry interface. So nothing to do for the time being. However, at this point, I think I will monitor surface here. And very shortly we should pass into the atmosphere suddenly. We'll do Celsius once that happens.
Mach 6.
Okay, as announced, we have just suddenly entered the atmosphere. I think I'm probably going to, well, I did say that I was going to want to do a atmospheric module anyway. Obviously, this is unrealistic because it thinks that it's 59.6 degrees Fahrenheit, when in reality, it's probably negative 359.6 Fahrenheit. So we're just going to drift down for the time being, although I am starting to see, yes, our air flight control surfaces are reacting. However, you'll notice that the landing time is over an hour from now, which means if we activate the APU now, we're going to run out. So I'm going to delay it as long as I can by running angle of attack without the APU. So if I hit AOA...
APU offline.
Now it's going to... Is it going to do it? Yeah, it's going to do it. Okay, so I guess it just doesn't want to auto-start. That's fine. I don't want to auto-start right now. I just want to hold attitude as much as possible. Alright, so it's going to be a long drift down. We're about an hour from landing. Alright, I'm going to start the APU now, and we're going to go to pitch and increase the elevator trim here to assist.
Off.
Okay, at this point it's becoming unavoidable. I'm going to have to engage the attitude hold autopilot, and if it has to start the APU to do it, then so be it.
APU auto start. Center of gravity shift online. Mach 5.
So having done that center of gravity shift, I also might be able to disable the autopilot at this point, and we might be able to sit where we are. Let's see, we'll use, I think it was 0.4 for center of gravity shift, 0.4 apt. I have to be really careful about using this thing, though. That's too much. So now I can power down the APU, and I've got center of gravity shifted, so it should keep us about where we are and want to be for a period of time.
Mach 2.
So apparently if you press PG when you're low enough, it'll actually show the surface of Titan, which is pretty cool.
Subsonic.
And so ends the slowest and most boring re-entry ever. So, now being subsonic, we still have a ways to go before we're below the clouds, but the direction looks good. So far, all I'm doing is just keeping the aircraft aligned with the velocity vector, basically in free what's it called? Free glide, with the elevator trim up. And I have everything offline in order to save, or conserve rather. Our position is expected to be right, landing right next to Sionis Pi Lacus, but we're going to be about 6 degrees north. But on Titan, when you talk 6 degrees, you're talking, it's a really small number. If I calculate it right now, yeah, it's like 267 kilometers, so we're going to be very close. We can try to see it. Nope, not seeing through those clouds. We're going so slow that we actually stalled. So right now our position is 50 degrees north and 83 east. So at this point, having stalled, the only way to increase our distance would be to turn to base. So what I'm going to do here is go to base sync. And looks like the heading is 120 degrees or so. So we'll go in that direction.
Pitch. Off.
Okay, we're finally starting to get into the atmosphere. You can now start to see an orange haze and it's turning blue. And then suddenly it will turn orange again. Once we pass through the clouds, you can now see quite a bit of cloud detail here. Still can't see the surface. I mean, I can't see the surface at all. So we have to pierce those clouds for us to be able to see Sionis K. Lacus. Alright, good news, folks. We are right over Sionis K. Lacus right now. 81.88 east, 42.5 north. So we're within 0.3 degrees, which on Titan corresponds with a difference of about 4 miles. So at this point, I'm going to hit track to drop off the location of the moving map. And now what I'm going to do is fly the craft in a spiraling pattern to stay within this border of the map. And here comes the hydrocarbon cloud layer. We're going to pass through the clouds now, and it's going to take on a blue and orange hue in just a few seconds. Look at that. Isn't that amazing? We're now below the methane cloud layer, and it's a wall of blue and orange. I love it. And from this point forward, the only star we can see is, well, it's not a star, the planet Saturn. Alright, so at this point I'm going to turn around and start heading back the other way. Let's see, Sinus K should be down there. It's going to be really hard to tell because of the cloud shadows. Probably one of those dark spots. Let me see if I can pull up a picture of it. So the current pressure outside the spacecraft is about what we would experience at about 15,000 feet on the Earth. But there's no oxygen, which means it's not breathable. However, you would be able to exit or at least depressurize the craft and not have to worry about depressurizing like you would in space. But you should bundle up because it's about minus 300 Fahrenheit, despite what the temperature display says, which is incorrect. And the combination of low gravity and high density basically means that we're in the equivalent of swimming, basically. I mean, this is probably a lot like the dynamics that would be experienced if the spacecraft were to fall underwater. I think it's those dark gray spots. It is really hard to tell, though. It all looks the same. I guess what I need to be looking is in the orange areas. Now there's enough pressure to feel 8,000 feet on the Earth. You can just barely see Saturn up by the altimeter HUD, or altimeter on the HUD, rather. Alright, we'll switch over to HUD 5 now. We are currently experiencing the Earth's atmospheric pressure at sea level in just a moment, and we're still at 80,000 feet. Actually, 85,000. Okay, and right now we have just surpassed the Earth's atmospheric pressure. If it was simulated at this point, we would have to open up a relief valve and turn the heaters on very high, or start shoving more air in through the pressurized tanks to increase the pressure. Because at this point, instead of acting like a spacecraft, we are now acting like a submarine. Both in control and in compression. We're now 66,000 feet above Titan's surface. It's a shame that this isn't more simulated. Maybe that's the spot. If that doesn't move, but everything else moves relative to that, that could be it. Yeah, I think it might be these gray spots. $45,000 feet above the surface of Titan. $30,000 feet above the surface of Titan. $20,000 feet.
$5,000.
15,000 feet.
4,000.
Okay, we're going to begin running through the rest of the checklist. APU on at this time. We're close to the surface. Let's see. What's our... Oh, it's only 2.2 kilopascals. Hover doors open. Retro doors open. And that's going to cause us to decelerate just a bit more. We should also put the gear down in just a moment. Let's see. Display HUD surface. 10,000 feet up.
$3,000.
Alright. AF control
Pitch
surfaces on.
Gear
Gear
down.
going down. And now we need to prepare the descent hold autopilot.
Gear down and
We want it
locked.
to hold a rate of 0. 7,500 feet above the surface now.
2,000.
And I need numbers real quick. 31,045. And
You are cleared to land.
21, 2.8, yep. V161. Alright, here we go. We have the
1,000.
VLAN checklist. Arceus
900.
mode as desired.
800.
APU on, gear down, hover, retro doors open.
700.
Lights not necessary, APU as desired on. Autopilot as desired.
Information. APU fuel 80%.
Actually, I want to have it hold the attitude. Nope, set pitch, and we want to set 0 degrees of pitch. Engage. I will control the velocity vector myself. So this is a gray spot.
600.
I'm guessing that to be Cyanoscape. So we're going to decelerate now to null. And I'm going to start adding hover thrust to control our descent speed here.
500.
Okay? We're at 10 meters per second. We're going to hold 10.
400.
Coming down, here's the shadow. Right next to that gray spot, which as far as I can ascertain is Cyanoscape Galactus.
300. 200.
Alright, slowing to 5 meters per second.
$100. 75. 50. 40. 30. 20.
Okay, here we go.
15. 10.
Alright, slowing to
8. 6.
contact speed.
4. 3. 2.
Expecting
1.
contact with the surface any second now.
Touchdown. Lift off. Touchdown.
Okay, we have contact, hover thrust off, brakes activate, and we have to disengage the attitude hold autopilot.
Wheel stop.
We have touchdown on Titan. So by the numbers, we're 0.07. Actually, let's worry about that later, right? We have a stay checklist, okay? So we've landed. We want to run part of the shutdown. AF control off.
Pitch. Off.
I'm going to recenter the elevator trim here. RCS mode off.
Off.
Tertiary HUD off. Secondary HUD off. Primary HUD off. Temperature display, degrees Fahrenheit. Lights off. Mission elapsed timer, we're at 1467 days. That's noted. Cabin hatch closed. Then we'll do nose cone open. And we want to do bay doors open. Okay, and we'll set this onto the surface of Titan.
Payload deployed.
There it is. Open up the inner door. We're going to hop inside the airlock now, close the inner door. Evacuate the airlock.
Airlock depressurizing. Airlock pressure 0 psi.
Okay, here we go. We're about to see the surface of Titan.
Warning. External pressure higher than chamber pressure. Outer door is locked.
Oh, maybe I'm supposed to leave. Okay. I didn't think about that.
Airlock pressurizing.
You're supposed to leave the pressure in there.
Information. APU running. Airlock pressure 14.7 psi.
Okay, but we need it higher than that, right? We need like a 22 psi. Let's see what happens now. Okay, well, it's not going to complain. What a view. Alright, let's do our calculation. So, how close are we to Sionis Caglacus? Well, we're at 81.71 east, 42.43 north. NASA says that Sionis Cag is located at 42.5 north, 81.88 west. So if I subtract and get a delta, we have 0.07 and 0.17. Okay, looks like we're about 5.57 kilometers away from the lake, and considering it's a lake, you know, we're talking a 3-mile distance. It's probably this gray spot right here. Whoa. You know, considering we're talking a lake, I'm not exactly sure how big it is. So, but we're close enough that it should be walkable in either case. So we're here.
Okay, so having landed, we get our final numbers now. Obviously, we're stopped on the ground, so V2 is 31,010.714. Mass starting at takeoff 2,088.7. Okay, so this was the first really bad one. That was 3 times more than I was expecting. All right, and just observing, we have 2,088 in the tank, 1,724 we need, which means we have a margin of, looks like about 350 kilograms. Yeah, 365 kilograms. So our margin has actually grown. It's looking good. After this point, the only really big one is the Titan Ascent. And if we can survive that, fuel-wise, then going out to Iapetus is a bunch of small burns. And then at the very end, coming back into Earth, that's the crazy one.
Okay, so the last thing we want to do is consult how many days of oxygen we have. Remember, we should be exactly halfway through our 14-year mission, which means we need 7 years of oxygen. So if we do 4938 divided by 365, we still have 13 years, so we could almost do the mission over again. Basically fly to Earth and come back and just be out right before we get back, so that's okay. External cooling, or not external cooling, but the coolant temperature is down, radiator is deployed, which means we are safe. So let's try this again. Hopefully this time we don't have the gravitational glitches.
Egress successful. Egress successful. Egress successful. Egress successful.
Alright, let's try things out. Hopefully they work well. Alright, it's working. Perfect. Alright, so I will oversee operations here. We're going to want to go to the UGCO payload adapter now. And I think it's Shift-C to release the cargo. So we've got a flag kit, a control module, and a light module. Perfect. So we'll have Galileo start, since Cassini did the probe. The first thing we want is the flag. So have him grab this flag kit here. With the G, there we go. Much smoother. See, this is what I was hoping to do in Enceladus, but that's fine. We'll set it down there and press U to unpack. And there's our flag on Titan. Alright, now we'll take Kepler, and Kepler will work on setting up the base. We definitely want this in the sun. So we'll move this back and put it on... Let me see which direction I'm facing right now. If I set this down, no, it'll tell me. Well, I think the sun just rose, so it should be in the east. Really hard to see with all the clouds. Right. Oh yeah. I just use the flag shadow to tell me. Okay, there it is. So that's east. So south is this. Okay, yeah. We want it on the starboard side of the XR2 Raven Star. Excuse me. A little bit more room. Alright, we'll drop it here with G, and let's get a base.
Unpacking cargo.
There we go. We now have a base on Titan, and I'm inside, which means if I Alt-X, I should get a healthy atmosphere.
Analyzing. Atmospheric pressure nominal.
There we go. So we now have our spacesuit off in the base, and you can hear the Titanian winds outside. Go back to Cassini, and Cassini will grab the life module, and this is the last thing we have to set up. So we only have 3 cargoes after we drop the probe off, and one of them is set up, the flag. 2 of them is set up because we also have the life module. So this is the 3rd and final one. And this one is going to be a little bit of a goof. It's going to be like, we're going to be like Superman for a second, because what's going to happen is we're going to unpack this thing, and then we have to basically move it so that it's in a safe location. So let's try right there to start. Okay, and as I expected, it's 90 degrees off, so let's try to fix that. Let's get these doors to line up. Alright, right there. Oh my goodness! What was that? Is it coming back? Oh, it's coming back down. Alright, I'm getting out of here. I have never seen it do this before. Oh my gosh, the thing is on acid. Alright, let me see if I can command this to the ground. All I did was drop it, and it just went crazy. Alright, what is this? It's Module 01, edit location on ground, copy state from... Copy from the control module. Okay, it's on the ground. Let's try this a different way, okay? We'll just shift it, and then move it to heading of 100, apply. Okay, this looks a little bit more promising. Okay, I think we've got it now. So, Alt-X.
Analyzing. Atmospheric pressure nominal.
Okay, good. She's not dead. Or, who is that? Galileo? Now we're going to go right in between the 2 modules. As in between as we can go. Which is probably right about there. And Alt-X again.
Analyzing. Atmospheric pressure nominal.
Okay. Alright, and we're in the life module. One more time.
Analyzing. Atmospheric pressure nominal.
Perfect. So as long as it doesn't take off again, in fact, let me save. As long as it doesn't just go crazy, we'll be safe. And you gotta be really, really careful moving around when you're in these bases, because you can move through walls like a ghost, and if you do, you will instantly suffocate. So don't do that. It's like Minecraft. Alright, let's see. Galileo. Actually, it wasn't. It was Kepler. Okay. By the way, they have ads in oh, we'll worry about that later. We get the rest of the crew in. Cassini. Oh, Cassini did that. Okay, so Galileo's outside, now I'm outside.
Analyzing. Atmospheric pressure nominal.
Alright, Galileo's in place, and lastly me. Everything is set up here. We have the cargo container there, we have the flag is set up here. XR2 is totally unpacked and secured, although I probably should have closed the retro doors, but whatever. Nobody can control it now because nobody's on board. And then we have our swanky new base here. And you can see Saturn right there, and up here should be the sun. Luckily, we're in a thick atmosphere, so there's no need for the gold filter. We're able to see things in clear. So go ahead and enter the base now. And position right there.
Analyzing. Atmospheric pressure nominal.
There we go. So interesting. It says pressure 154 is okay. And that's true. I mean, but you wouldn't want 21% oxygen. You want 15% oxygen. But 154 kilopascals is easily tolerated by the human body. Just go 12 feet down in a swimming pool and swallow, and that's what it would feel like. No problems whatsoever. Now I want to go back into the control module. And there's actually I was saying there's an ad here. Be a UGCO architect, design stunning, what does that say? Fixed or cargo base, no programming required. It's easy. Go to the UGCO document. Okay, fine. So if we really wanted to go crazy, like her face. Is that supposed to be a joke? Why would an astronaut ever put that face on? Anyhow, I love this. It's like we built a small city here, and that's exactly what the goal was. So get my pictures in. And that's what it's all about. Alright guys, this is it. I think I'm going to split the video into two parts here and do the Iapetus video on its own, because getting into Titan was a little bit difficult, or a little bit more difficult than I had planned on. So this will be a 9-part series. We'll next time we fly to the Iapetus, and then in the 8th episode we'll return to Earth. The 9th episode we'll debrief everything. So thank you guys for joining me on this flight to the beautiful, beautiful Titan. Very, very nice moon. One of my favorite locations in the entire solar system that you can currently go to. I'm working on getting an assortment of add-ons together to go to my favorite place outside of Earth in the solar system. So stay tuned. I've been Dr. Aeronautics, and I will see you guys next time. Bye-bye.